Can you see my screen?
Yes, sir.
Okay. So I'll restart from the last one. Yeah, so I'll restart. So in the last class, we started with IP version for addressing, right? So we saw the formats and how the whole network address, broadcast address works and whatnot. But that was just the introduction of the IP version for addressing. So there are more things to it, which is subnetting. We call it subnetting. Why is it called subnetting? It's because this network that we have, say we in Brack University, we took a network of size 1024. So anything that we calculate, all the numbers, total numbers that we calculate in the IP version 4 space has to be a power of 2. It cannot be anything else. It cannot be 1000 because it doesn't fall under in the power of 2 space. Why is that? Because whenever I divide the bits, so I cannot divide them in half, right? Whenever I divide, I have to divide them separately, like as a whole. So I either have 15 bits in network or 16 bits in network. I can never have 15.5 bits in a network and the remaining in the other space. So it's always a distinct division, right? So anything we decide, we have to what? Divide in number in 2 to the power something. So say I have this whole network of 1024 size, which is 2 to the power 10, all good. Now, first thing is that 2 of the IP addresses is not usable by me, right? So I can actually use 1022 as the number of hosts. That's gone. Anyway, so when I'm doing subnetting, I do not need to consider the broadcast and the network address when calculating the subnet, but within the subnet, we will consider those 2 addresses. For example, this 1024, I brought the whole network here, but I do not need this big network. I want smaller networks. So I can divide it to smaller networks of 256. Right? So in 1024, I can make 4 blocks of 256 sized networks. So this is my main network, while the branches that I just brought up, the child or the children, are called subnetworks. Subnetworks. So subnetworks in short is subnet, right? So even from here, from 256, I can bring out even more branches, say 128. From 128, I can bring out 32. I can like bring out 432s. If I chose 8, I could have brought out more branches, but it's according to what I need. It's not not my own choice. I have to decide based on the scenario given, which we will learn in a bit. So far clear. So if you notice, I did not consider the broadcast address and network address when dividing like this. But within this network, whenever I am working with this particular network, when I assign host, I will be considering only 254 hosts, not 256. So the number here is the total subnet size, including the broadcast address and the network address. And whenever we start working with a particular network, we're going to consider the two less hosts. Any questions?
The last part पूछना मुझे less host बोलने consider करना
अच्छा, so our subnet size तो 1024 কেন 1024 because এখানে আমি network আর broadcast কে include করছি ঠিক আছে আমার subnet size is not equals to host size ঠিক আছে subnet size is everything. Subnet size is host plus network plus broadcast, everything that there is in that network. Host size is only the host without the broadcast and the network. এতটুকু কি clear?
Yes, sir.
Achha. So the numbers I used in this tree are the subnet numbers, not the host numbers. Clear? So when I make this tree, I will be giving the total subnet size, but when I say I am asking you to assign this network to some particular person or a particular office. So here, how many IPs can I assign? 256 or 254?
254.
254 because I cannot assign network address and broadcast address. এখন কি clear?
স্যার ইচ যেগুলো আছে চারটা যে ডিভিশন এই সবগুলাতেই তাহলে 254 টা আইপি অ্যাড্রেস ইউজেবল হবে।
Yes, ইউজেবল। এই প্রত্যেকটা ব্লকে হচ্ছে দুইটা লেস করে ইউজেবল। বুঝা গেছে? মানে I cannot use this network because this network is being divided, right? Whenever a children or a child is divided, I cannot use the subnetting. I need to use the child, only the tertiary childs.
Excuse me, sir.
জি স্যার।
স্যার তাহলে আমরা যতবার ডিভাইড করব অতবার দুটো করে লেস হবে নাকি
না
জাস্ট?
না ওটাই বললাম, আমি লাস্টে যেটা বললাম যে এই যে I divided this, right? This 256.
Yes, sir.
I cannot use this particular net anymore. I have to use their children. But আমি যদি ওর children-এর কাছে যাই, if I go to their children, can I use this one? I cannot because this was further divided. But
Yes.
the one on the right, this square one, rectangular one, did I use it?
No,
Did I divide it? I did not. So I can use this one. So here I will get 126 hosts.
Okay, sir.
Okay. So yeah. So far clear? So I can have as many childs as I want as long as I have the IP address possible. So I can, from 8, I can create 2 4s, right? From 2 4, I can create 2. From 2, I can create 1. This is not possible. Can you tell me why? This subnet of size 1, right? And this subnet of size 2, these are not possible. Why?
Because there are only 2 networks then, and both of them will be unusable.
Yes, so for the subnet of size 2, it's network address and broadcast address. You cannot assign any host, so this is useless. And because this is useless, their children is further useless. Clear? All right, so how do we subnet this whole thing? How do we use the subnetting in the IP address? So previously we learned that an IP address, say 10.0.0.0, can be divided into 2 parts. One part is network N, and the other side is the host, right? So the total summation of this is 32 bits. Right. Now, as I told you before, that the network portion is not editable. I cannot do anything with it. The network address that is given to me is my identity, and I cannot modify it no matter how much I want to. Clear? So anything that I do, I need to do with this host part. Clear? So using the host part, what I can do is I can further subdivide it into 2 parts. So always the rightmost side is the host part. Always in an IP address, the rightmost division is always the host. So when I further divided it, the main host part, the right-hand side would be the host, and the left side would be something that we called is a subnet ID. It's a unique ID that's given to a subnet. Did you understand the division of the IP address?
স্যার আমরা আগের লেকচারে যেই ডিভিশনটা পড়ছিলাম এটা কি ওটার মধ্যে ইনক্লুডেডই ছিল, জাস্ট আমরা ওটা স্টাডি করি না এরকম?
হ্যাঁ ওইটাই আমি ওটাই পড়াচ্ছি।
আচ্ছা
ওইটাই এখন পড়াচ্ছি ডিভিশনটাই। So there's the network part, all good, right? I cannot modify it. I have the remaining host part. So the scenario is I am an ISP holder, I'm an ISP provider. So I bought this particular network, this 1024 IP addresses, right? And I will be giving my network, I'll be subdividing my network to sub networks, to smaller networks. For example, I provide internet to Dhaka, right? So I got this huge number of 65K, huge number of a huge network. But I don't want to use the whole thing. I want to divide it into different areas of Dhaka. Say I want to give one to Mohakhandi, I want to give one to Uttara, another to Bonostri, another to Rampura. I want to subdivide it. So what I do is I divide them. And give them to the sub areas. Clear? So this division, the network address given to me, I cannot modify it. As a result, I have to do that within the host bits that I have. So kotha, if I have 16 bits here, say it's /16, the first 16 bits I cannot touch. The remaining 16 bits, I can do whatever I want. Clear? So in that remaining 16 bits of the host part, I have divided into two parts. One is subnet ID and the other one is host. Any questions?
স্যার একটা কোয়েশ্চেন ছিল বাট ওটা যে
বলেন।
আগের পার্ট থেকে স্যার
বলেন
আমরা
স্যার।
যখন ইউজেবল অর নট ইউজেবল বলি তো স্যার
হুম।
ব্রডকাস্টের যেটা ছিল ধরেন একটা নেটওয়ার্কের আইপি তারপর লাস্টে ডট দিয়ে 255 তো
হুম।
ওটা তো স্যার অ্যাকচুয়ালি ইউজ হচ্ছে বিকজ আমি যদি ব্রডকাস্ট করতে চাই
হ্যাঁ।
তখন তো স্যার আমি ওটা ইউজ করতেছি তাহলে স্যার ওটা আমরা কেন কনসিডার করতেছি না ওটা তো
আচ্ছা,
অ্যাজ
it's
হোস্ট
not
ক্যালকুলেশন
usable. It's not usable as a host.
আচ্ছা
That's what we meant by the usable IP address.
ওকে স্যার অ্যাসাইনমেন্টে এরকম একটা কোয়েশ্চেন ছিল যে কোনটা ইউজেবল না বাট ওখানে হোস্ট মেনশন ছিল না সো ইন দ্যাট কেস কি আমরা
Oh
হোস্ট
yeah, it's always that. It always means the same thing. Usable is always the host part, and unusable is the broadcast and network part.
আচ্ছা ঠিক আছে স্যার এটা একটা কনফিউশন ছিল
Okay. So if you're okay with it, now we will see how this subnet works, right? So in the subnet part, this part becomes the subnetwork's network portion. So I have this original network already. In addition, I will be considering the subnet ID part as the subnetwork's network part. And this host is subnetwork's host portion. Okay. So for example, let's see. I have this IP address 10.0, right? I'll give this example 10.0 dot 0.0000000.0000000. I broke it off here because it's 16, and after 16 bits, I need to work with it. Okay. Now, say I want to create hosts of size 200 hosts per network. How many bits do I need to give it? Can anyone tell me? I want to create subnets of size 200 hosts. 200 hosts. How many bits do I need to represent this 200 hosts?
8.
I need 8 bits. How did you calculate that?
2 to the power 8 to 56.
Right. So everything, as I said before, everything needs to be calculated in power of 2. So in power of 2, if I consider 128, it's not enough to satisfy all 200. Above 128, the next combination is 256. 256 helps, satisfy 200 hosts. So it's like buying those platters in the restaurants, right? So if you buy one, it's for 3 or it's for 4, but you 3 went, right? So say 3 of your friends went, but the platter says it's for 4, but it's a good deal because if you want to buy individual ones, it would cost more. So in these scenarios, I need to buy the minimum threshold that satisfies my 200 hosts, right? So this is 200 hosts plus I need 2 more IP addresses to represent the network and the broadcast address. So say I have my host requirement is 256. How many bits do I need now? 8 bits or 9 bits?
স্যার 256 এর জন্য
Yeah, 256 hosts.
স্যার 8
9 bit
9 bits. Why is that?
because there are 2 addresses I cannot use.
Right. So if I use 250, if I take 256 bits and say I will use 8 bits, if you notice, there are no IP addresses free to be assigned as the network address and as the broadcast address, right? So because of that, I always need to check the number of hosts plus 2. What does that come to? It becomes to 258. And to represent 258 numbers, 256 is not enough anymore. I need 512, and 512 is 2 to the power 9. Okay, so it becomes 9 bits. Confused?
স্যার 2 অ্যাড করলাম কেন এটা বুঝি
আচ্ছা, সো আমার নেটওয়ার্কে তো আমার যে নেটওয়ার্কের দিক না কেন সেই পুরো স্পেসে আমি কি সবগুলো ইউজ করতে পারবো নাকি দুইটা কম ইউজ করতে পারবো?
এটা কম
দুইটা কম। তো আমার দরকার কি 256টা হোস্ট, তাই না?
Yes, sir.
তো আমি ওকে যদি 8 বিট দিই তাহলে আমি কতগুলো আইপি পাচ্ছি? 256টা আইপি পাচ্ছি না?
Yes, sir. আচ্ছা স্যার, got it.
বুঝছেন? এই তো।
হুম।
আর কোনো কোয়েশ্চেন? Okay, so with the original question, I had the requirement of 200 hosts, right? So for this, I need 8 bits. So for the host bits, I'll count from right to left. So 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. I'll be drawing my line here. There. So 2 to the power 16 is what? It's something like 65,000, 65K, right? So my main network, this whole network had used to support 2 to the power 16 IP addresses, right? So 2 to the power 16 equals to 65K. But my requirement is only 200 hosts, not 65,000. So I'll be giving him only that part, the bits that they require. Now, if you notice, I can change this host part. I cannot change this subnet ID part, and this is the network part, right? So in the host part, this will eventually come to this scenario all once, right? I mean, একটা পর একটা কাউন্ট করতে করতে আস্তে আস্তে এটা সবগুলো ওয়ান হয়ে যাবে না হোস্ট পার্টে? What will happen after this one?
ব্রডকাস্ট মনে হচ্ছে স্যার তাহলে।
এটা তো ব্রডকাস্ট, বাট কম্বিনেশন ওয়াইজ এইটার পরের কম্বিনেশন কি? Isn't it this one? One. এটা না?
Yes, sir.
Right? Just binary counting. So if you notice, subnet ID, did it change? Did the subnet ID value change? It changed, right? It was previously 0 and now it became 1. So in this space, it had 256 combination. It will again have 256 combination, right? How many combinations of 256 can I have with this subnet ID space? বাংলায় বলি, দেখেন, হোস্ট পার্ট তো হচ্ছে আমার হোস্ট পার্ট, নেটওয়ার্ক হচ্ছে আমাকে মেইন যে নেটওয়ার্ক দিছে, তাই না? সেটা হচ্ছে আমার মেইন নেটওয়ার্ক। এখন আইএসপি লোকটা কি করতেছে? আইএসপি লোকটা বলতেছে আমি এত বড় নেটওয়ার্ক ইউজ করবো না, আমি আবার এটা ছোট ছোট করে ভাগ করে দিব। ও কত করে ভাগ করতে চাইছে? 200 করে ভাগ করতে চাইছে, ঠিক আছে? এখন 200 করে ভাগ করতে চাইলে ও করছে কি, ও হচ্ছে এখন সাবনেটের হোস্টের জন্য কয়টা বিট লাগে সেটা বের করছে। সেটা কি বের করছে? 8 বের করছে, ঠিক আছে? এখন এই 8 বিট তাহলে আমরা রাইট থেকে কাটবো। এই যে একদম লাস্ট বিট আছে না এলএসবি, এখান থেকে 8 বিট কাউন্ট করব, এই পর্যন্ত আসছি, ঠিক আছে? এখন তাহলে প্রথম 16টা নেটওয়ার্কে চলে গেছে, লাস্টের 8টা হোস্টে চলে গেছে, তাহলে বাকি থাকে আর কয়টা বিট? 16 প্লাস 8 কত হয়? 24। তাহলে 32 মাইনাস 24, আরো 8টা বিট বাকি থাকে। এই 8টা বিট কোন জায়গায় যাচ্ছে? 8টা বিট এই যে সাবনেট আইডিতে যাচ্ছে, তাই না? এতটুকু কি ক্লিয়ার?
স্যার
আচ্ছা, এখন সাবনেট আইডিতে গেলে এখন চিন্তা করেন, আপনি হচ্ছে এই যে 65,000 আইপি অ্যাড্রেস আছে, এখানে আমি এখন 256 করে ভাঙা শুরু করছি, ঠিক আছে? আমি কতগুলো 256 বের করতে পারবো 65,000 থেকে?
4টা।
2 to the power 16.
2 to the power 16? দেখেন 65,000 divided by 256 করেন। So the idea is how many IP address, how many blocks of 250 size 256 can I bring out from this 65,000? For example, I have the number 10. How many 2 can I have in a 10?
254.
5
5. 2, 2, 2, 2, 2. 5 children of size 2. Similarly, how many 256 can I have in a 65,000?
ক্যালকুলেটর বলতেছে
253.
253.90।
মানে 2 to the power 16 করেন, 2 to the power 16 করে তারপর ডিভাইড বাই 256।
So 256 হয়।
256 হয় কেন? দেখেন সাবনেট আইডিতে কয়টা বিট? 8টা। এই 8টা বিট দিয়ে কয়টা নাম্বার রিপ্রেজেন্ট করা যায়? 256টা। So I can have 256 networks of size 256. Does that make sense?
Yes, sir.
আচ্ছা।
কনফিউশন থাকলে বলেন, I'll repeat again কোথাও কোনো ভুল হলে।
Of size 256 দিয়ে বোঝাচ্ছে স্যার ওই যে
সাবনেটের সাইজটা, সাবনেটের সাইজ।
আচ্ছা বুঝতে পারছি।
ঠিক আছে, so just for an example, let's practice something, right? So I have this IP address 10.0.0.0/15, and I tell you to create subnets. How many subnets can I have if the host size is 512? How many subnets possible? Can you figure this out?
Is that
Not
15?
512, that's 1024.
Is that 15?
That's 15, yes. So my network address is 15 bits, the first 15 bits, and I require you to make a host, a subnet of size 1024, a host that satisfies 1024 hosts. How many subnets can I create? So I have 2 to the power 17, which is what? One three one zero seven two. I have these many IP addresses, and I want to divide them into hosts, into subnets that can carry 1024 hosts. How many subnets can I make?
So 128.
Okay, one answer came to be 128.
Yes, sir, 120.
Any other answers?
32.
Another one said 32.
স্যার এখানে একটা কোয়েশ্চেন করি।
Moran, sir?
স্যার আগে এখানে লিখছিলেন 256 নেটওয়ার্কস অফ সাইজ 256, এই সাইজটা কি স্যার এক একটার সাইজ
Subnet size. Subnet size, হ্যাঁ, এক একটার size.
একটার সাইজ 256 কেন স্যার?
কারণ হচ্ছে আমার দেখেন সাবনেট আইডিতেও কতগুলো বিট?
8টা।
8টা, তাহলে 2 to the power 8 কত?
6। ও আচ্ছা আচ্ছা।
So let's see. Let's break this down. So I have this again to 10 dot. I have to break this one now because 15 intersects with the second octet. Right? This is where I break off. 2 3 4 5 6 7 8. 2 3 4 5 6 7 8. This is my IP address, right? Now in 1024, my host requirement is 1024, right? I need additional 2 IP addresses to represent the network and the broadcast. So it becomes 2026. And to represent 1026, I need 2048 IPs. Right? So far clear?
Yes, sir.
How many bits do I need to represent 2048 IPs?
11.
11 bits, right? So my host size, my host space size has to be of 11 bits. So I'll count from right to left. So I have till 8 here and 3 more here. So I'll be drawing a line here. So this is my network portion, this is my host portion, and the middle one is my subnet ID. How many bits do I have in the subnet space?
6।
6, right? So 2 to the power 6 equals to what?
64।
64. Is that clear how I calculated the subnet? So I can have 64 subnetworks of size 1024 of size, sorry, 2048 each. Does this statement make sense now?
স্যার এটা সাবনেট সাইজ হওয়ার লাগবে না?
হ্যাঁ, subnet size.
তাহলে স্যার এখানে তো 6 বিটস, তাহলে 64 হবে না সাইজ আগেরটা যেভাবে বলছে?
64টা সাবনেটওয়ার্ক, প্রত্যেকটার সাবনেট সাইজ হচ্ছে 2048. 64টা হচ্ছে আমার নেটওয়ার্ক কয়টা পসিবল হলো। 2048 হচ্ছে এই 64 প্রত্যেকটার সাইজ। আপনার 64টা রুম পাইছেন, প্রত্যেকটা রুমের এখন সিট নাম্বার হচ্ছে টোটাল 1048। ডাজ দ্যাট মেক সেন্স?
স্যার এই সাইজ যেটা বের করলেন এটা কি ওই যে হোস্টের বেড নাম্বারের উপর বেস করে বের করা
হ্যাঁ হ্যাঁ। আর একটা এক্সাম্পল দিই, আর কারো কোনো কোয়েশ্চেন আছে? না থাকলে আমি আরেকটা এক্সাম্পল দিই। সেম কোয়েশ্চেন, 10 to the power 000 15 create 15 subnets. সাবনেট সাইজ কি হবে তাহলে? সো আপনাকে নেটওয়ার্কটা করতে দিচ্ছে, এখন ইউ হ্যাভ টু ক্রিয়েট 15 সাবনেটস এন্ড এখান থেকে 15টা সাবনেট তৈরি করলে আপনার সাবনেট সাইজ কি হবে এইটা একটু আমাকে বের করে বলুন। সাবনেট সাইজ হচ্ছে ব্রডকাস্ট নেটওয়ার্ক সহ।
স্যার এটা কি 2 to the power 13 হবে?
What 2 to the power 13?
Yes, sir.
আচ্ছা, একটা আনসার আসছে, লেটস সি if there's any other answers. So let's see. Again, I have 10 to the power 0. My line will be drawn here. Right? This is what's happened. Now, to represent 15 subnets, how many bits do I need?
4 bits.
Why 4 bits? Why not 3 bits?
So 2 to the power 4 which is 16 by so 3 to
Right.
2 to the power 3 is
So in the binary space, I cannot get this number exactly, right? 15. I either have to go with 18 or 16 or 32. So 8 does not satisfy, 16 satisfies, 32 is hence not required. So to represent 16 numbers, I need 4 bits, right? So 4 bits. So in network, I have the 15 bits. In subnet ID, I have 4 bits. So 15, 4. That totals to 19 bits. So how many bits do I have remaining for the host bits? 13. So the total number of the subnet size basically is 2 to the power 13, and the host size equals to 2 to the power 13 minus 2. Is that clear?
So -2 কি ওই যে ব্রডকাস্টার আইপি জন্য?
হ্যাঁ, সাবনেট সাইজে তো হচ্ছে আমি পুরো আইপি অ্যাড্রেসের স্পেসটা দেখতেছি, রাইট? বাট হোস্টের সময় তো আমার দুইটা বাদ দিতে হয়।
বাট স্যার সাবনেট সাইজ কি তাহলে 2 to the power 13 হবে?
হ্যাঁ হ্যাঁ, সাবনেট সাইজ এইটা।
ওকে ওকে স্যার।
Is that clear? Any questions, anyone? Okay. So if that's clear, I will move on to the next part, which is the heart of subnetting. So in subnetting, I have 2 types of subnetting. The first one is classful. The other one is classless. In classless, I have again 2 types. The first one being FLSM, and the other one is VLSM. Yes. So starting with the classful first. So we have 3 classes of IP addresses: class A, class B, and class C. When we are speaking about classful IP addresses, we have 3 fixed types of IP address. In class A, 8 bits are network. So network and host, I'll just draw it like this. So 8 bits are in network and 24 bits are in host. For B, it's 1616. For C, it's 24, 8. This is a fixed thing. So whenever there is a, what do you call it? If it's a class A IP address, if I say this is a class A IP address, you have to calculate that, or you have to decide, or you have to choose that the network address is /8. The first octet is the network portion. It cannot be /9, it cannot be /10. In classful IP addressing, these subnets are fixed. Clear? So this is fixed for the classful IP addressing. Now there is a start number, there is a range. Let me get that range. Here you go. So these tables. So class A, as you can see, class A has a range of 0 to 127. Class B has a range of 120 to 191. Class C has this to this, right? These are the ranges. These ranges are fixed. So it never can be like this. So if I say 10.0.0.0/16, this is wrong because 10 belongs to class A. So the network address or the subnet mask, prefix mask must be /8. Clear? These are fixed. Any question here? Okay. So which class of IP address is the most expensive? A, B, or C?
So A, I think. Because less number of networks.
Nope. So A is the most expensive, C is the least expensive. Why is A most expensive? Because it can support the largest number of hosts. Size borrow, right? Bigger the size, more expensive it is.
Oh, largest number of hosts.
Yeah.
Oh, that's
The network, you cannot touch network bit, right? So the more the bits is locked, the worse it is for you because you're not being able to access those bits, right? It's being given to you. You cannot do anything with it. Then, say you are given a burger, but you cannot eat half of it, right? So it should be less expensive. Are you, is this okay? Classical IP addressing? Okay. Now, the next one is the classless. In classless, we do not have these classful ABC classes. Everything is the way you want it. If you want /9, all good. If you want /10, all good. As long as you satisfy their protocols, they don't care what subnet mask or what prefix mask you used, right? It's not fixed like ABC. So in FLSM, it sees how many networks are there. So now in FLSM, so FLSM is fixed length subnet masking. Here's a fixed length subnet masking. So apart from here, what we need to understand is, say I have 1024 IP addresses. I have a network where there are 1024 IP addresses possible. The subnet size is 1024 or the network size is 1024. And I want to divide it into 3 networks. Right. Now, can I represent 3 with binary numbers? I cannot. I need it to be 2 to the power something. So to represent 3 subnets, I require it to be 2 square or 4 networks. So I have to divide it into 4 equal parts, which is 256. So it's like, I mean, if you have siblings, whenever our parents or someone brings something, your parents are like divided equally among all of your siblings, right? So if you have 10 siblings, you have to divide that particular food into 10 equal parts so that everyone gets equally, everyone gets equal food, right? So this is something like that. If my requirement was 10 subnets, now I cannot represent 10, I can represent 16. So this becomes 16. Now, 1024 divided by 16, what is that?
64.
64, right? All right, so 64, 64, and so on, total of 16 64s. Clear? So subnet, fixed length subnet masking works like that. Is that clear?
স্যার এটা কি বেসিক্যালি এই যে 2 এর পাওয়ার নিয়ে যে করতে হবে এটাই হচ্ছে ফিক্সড লেন্থ
হ্যাঁ হ্যাঁ সো ফিক্সড লেন্থে সবসময় ইকুয়ালি ভাগ করতে হবে, এটাই মানে আমার যদি দুইটা নেটওয়ার্ক থাকে তাহলে দুইজনকে আমি ইকুয়ালি দিব, যদি তিনজন থাকে তাহলে আমি চারজনকে ইকুয়ালি দিব, এরকম কোনো ডিসক্রিমিনেশন নাই, বুঝতে পারছেন?
Yes, sir.
And finally we have VLSM. VLSM is variable length subnet masking. So variable length subnet masking. This one says যার যতটুক দরকার তাকে ততটুক দিব. So it's basically whatever you need, I'll give you only that portion. If I need 1024, I'll give you 1024. If you need 512, I'll give you 512. Right? It goes exactly as you want. It's not equal division. It's not nothing. For example, in FLSM, say apni onek boro, you are the elder brother and you have a very small sibling, say a few years, who cannot eat a whole burger. In FLSM, you have to give the whole burger to your sibling and to yourself. So 2 burgers, you have to buy the 2 whole burgers because FLSM is all about giving food equally. Even though you know that your brother cannot or your sister cannot eat that whole burger. In VLSM, you will get yourself a big burger because you're a big guy and you can eat the whole big burger, but your younger sibling cannot eat the big burger. So you get a kid burger, a smaller burger, because their capacity is small, right? So I'll clear this up with an example. So we will see why do we need to move from classful IP addressing to VLSM. So classful IP addressing is the traditional way how we work, and VLSM is the newest method in trying to save the IP version 4 addresses, right? So the main target is to reduce waste. We moved from classful IP addressing to the, what do you call it, VLSM, to reduce the waste of IP addresses. So how does that work? For example, I have one host of size 120 and another host of size 5. And these are my requirements. I need to give networks to this particular host, right? In classful IP addressing, what I have to do is, for host A, how many IP addresses do I need? 120 plus 2, basically 122, right? That's the total number of IP addresses that I require to make a new network for host A.
Yes,
Is that clear why it's 122?
Yes.
All right. So for 122, how many hosts do I need to give in classful IP addressing?
128.
There are 3 classes.
স্যার একটা কথা এখানে হোস্ট এ অফ সাইজ 120 মানে কি স্যার এটা হোস্টের সাইজ এত ইউজুয়ালি
হ্যাঁ, হোস্টের সাইজ
সাবনেটের
এত
সাইজ
হবে।
হয় না স্যার?
না, আমি সাবনেট সাইজ বলি না, আমি হোস্ট সাইজ বলছি। তার মানে এটার সাথে 2 অ্যাড করতে হবে।
হোস্ট সাইজ বলতে কি মানে একটা হোস্টের কতগুলো ইউজার বা এরকম কিছু? Host
একটা
size?
নেটওয়ার্কের কতগুলো ইউজার, কতগুলো হোস্ট।
আচ্ছা আচ্ছা আচ্ছা, সো এই হোস্ট এরিয়া নেটওয়ার্ক এর 120টা হোস্ট এটা বোঝাচ্ছে।
জি।
ওকে স্যার, বুঝতে পারছি।
সো ক্লাস এ তে কতগুলো আইপি অ্যাড্রেস? How many hosts do I have in class A?
122
Class A, no. Let's see. Class A can support 16 million hosts. B can support 65,000 hosts. C can support 256 hosts. So which class of IP address would you give to host A to reduce waste? A, B, or C?
B sir highest.
Okay, so this is like saying you went to a restaurant for 122 people, right? And you ordered food for 16 million people. Does that make sense?
Oh, আচ্ছা স্যার লোয়েস্টটা দিতে হবে সি
the
Right. The lowest package that can satisfy this 122. So I'm taking 256, which is class A. How many IP addresses are wasted here? So you just subtract it, it becomes to 134. So why is 134 wasted? Because your requirement was 122, but you had to take the platter for 256 people. As a result, 134 plates were wasted because there's no one to eat. Right? Clear?
yes sir.
ইয়েস স্যার
Okay. For host B, the requirement is 7, 5 plus 2. Which class would you give them? A, B, or C?
The
ইন সি স্যার
Again, C, right? So I have to give them C because I need to reduce waste. How many are wasted here?
249.
249. What's the total wastage? 383, right? So my total waste is 383. Now, as I said, my target is to reduce waste. So I'll go to classless IP addressing now, and I'll start with FLSM. In FLSM, you can have what? Any number of, what do you call it? Subnetworks, right? Or you can choose the subnet mask or the prefix mask. So to satisfy 120, how many IP addresses do I need to give it? At least 128, right?
ইয়েস স্যার
So can I say, so since this is the biggest one, this person will eat the biggest one. So this is 128. So I can say I can assign 128 to this one as well, because FLSM is what? It's all about equality. If I give 120 to one network, I have to give 128 to all the others, right? Now, the best way to choose it is by choosing the largest network. So if I chose 5, 8 would satisfy him. Would 8 satisfy host A?
ইয়েস
No.
স্যার
It won't, right? So you always choose the largest network that you have, which is 120, and it requires 128. So you give 128 to everyone, right? So for A, your requirement is 122, and you give it 128, and hence what's the waste? It's only 6. So if you notice, the waste came down from 134 to only 6. For host B, its requirement is 7, and you have to give it 188 because equality. And here, wastage is what? 121. Again, not a good thing, but better than before, right? So what's my total waste now? It's just 127. So my total waste came down from 383 to 127. So far clear?
Yes sir. Sir, আমি এখানে হচ্ছে ইচ্ছা মতো চুজ করছি, বাট তারপর হচ্ছে 2 to the 2 এর একটা পাওয়ারে থাকতে হচ্ছে, তাই তো?
G, G. Now we have one more, which is classless, and it's VLSM. In VLSM, we believe in what? We give whatever is required. So for host A, it's 122, and I need to give him 128. The waste is 6, no improvement, right? For host B, its requirement is 7. So how many can I give him?
12 মানে 2 to the power 3
8,
8 okay
right?
2 to the power
So
3.
how many are wasted? Just 1, and total waste is 7, right? So if you notice, it's an improvement. So if VLSM does not nullify the wastage, it reduces the wastage. Clear?
Yes sir
Any questions from here?
স্যার এই যে অ্যাসাইন করতেছি লেটস সে যে 128 তারপর 8 এগুলো সব সাবনেট আইপি কতগুলা সেটার ক্যালকুলেশন
উপরে, হ্যাঁ হ্যাঁ, ওই ম্যাথটা আমরা এখনো দেখিনি, আমরা জাস্ট ক্যালকুলেশন গুলো দেখলাম। সিমুলেশনটা আমরা এখন দেখবো আর কি। Any questions? All right, so we will see the start of the subnetting VLSM math. So what happens is we do not use classful IP addressing. We do not use FLSM. We're going to start using VLSM. Clear? So VLSM has this simulation that we do. Clear? So in this simulation, what we do is say we are given a network. I'll draw a network. So I'll start the simulation here, but I'll complete the simulation in the next class on Wednesday, because this is kind of complicated to explain via screen. I kind of need to show a lot of things. Anyway, so in VLSM, the first thing that we need is the host configuration. Clear? So if I go back to this, nope, not this. For example, this one here. Yeah, let's screenshot this one. And yeah, ready. So first we need to identify two things. The first one is the network address. So here the network address is this, right? This is the network address given to me. I am to use this network address to divide everything. Here. So in here we have these LANs. So every router that has a switch connected to it is a LAN. So this one is a LAN, this one is a LAN, and this one is a LAN. Here. And these LANs, I have to put them into order of largest to smallest. So the largest one is 120, then it's 60, then it's 20. I have 3 hosts found already. In addition to this, these red ones, these are called WAN links. WAN link is wide area network links, the connections that are between router to router. These I have to consider as well. So in this particular scenario, what you have to understand is every router needs an IP address. Every port of a router needs an IP address. Clear? So in this one network, there is one, and here is another one. So 2 hosts. So my host requirement is 2. Again, in another one, it's 1 and 2. So that's another 2 hosts. Clear? So you might be asking why I did not consider this one. I should logically consider this one as well, right? So in exam, it will be mentioned if I consider this or not, right? We will learn it in the next class when I do the whole simulation. Right. So I'll be silent for a bit till the Azan ends. All right. So any questions so far? Okay, if not, let's go back to our thing. So in Velasum, I had this host requirement, which is 120, 60, 20, and 2, 2. Right. So what I have to do with this, I have to figure out how this metadata of this host, right? So what this metadata is a table. It's a long table. Let's see what that is. So this is my host requirement. Now for 120, how many IP addresses would I need? I would need 2 more, right? So it's 122, it's 62, it's 22, it's 4, this is 4. Clear? And after this, I have to figure out how many IP can I actually give it. I cannot give it 122, right? I have to give him according to the power of 2. So for 122, how many bits do I need to give it? Or sorry, not how many bits, how many IP addresses do I need to give it?
128.
128. For 62, it's 64. For 22, it's 32. For 4, it's 4, right? It matches, so it's good. There is no wastage, 0 wastage. So for 128, how many bits do I need?
7.
So host bits. So to represent 128 IP addresses, I require 7 bits. This is 6, this is 5, this is 2, this is 2. So if these are host bits, how many bits do I have for the network portion? So it's basically 32 minus 7 equals to what? 25. This is similarly 26. This is 27. This is 30. This is 30. Clear? So whenever I start with the VLSM simulation, it's good to create this particular table, right? And this has no marks. This is just rough work so that your VLSM simulation becomes easy. Does that make sense?
স্যার এখানে একটা জিনিস আমি বুঝলাম,
জি।
এই যে স্যার ফার্স্ট কলামে যে হোস্ট দেওয়া, এখানে
হুম।
স্যার লাস্টে যে দুইটা 2 আর 2 অ্যাড করছেন, এগুলোর
হুম।
পরে আবার +2 করছেন। সো এই পার্টটা স্যার এক্স্যাক্টলি বুঝিনি কি বুঝাচ্ছি।
আচ্ছা, so if you remember, the network was this, right? এটা ছিল না, এটা 120 ছিল, এটা 60 ছিল, এটা 20 ছিল, right?
নাম্বারগুলো কি রিপ্রেজেন্ট করতেছে স্যার?
Number of hosts.
আচ্ছা, ইন দিস নেটওয়ার্ক এরকম।
হ্যাঁ, so in one link I have 2 host requirements, right? Because it's দুইটা router এর দুইটা port.
Yes sir.
Hence 2. And this is a network, right? And since it's a network, it would need the network address and the broadcast address, right?
Oh yes sir, I understood.
So +2. Clear?
Yes sir.
Okay, so I'll end the class here and we'll see the remaining part on Wednesday. So I have just the tree left. What I have left is to show you the IP tree. This will require around 15 to 20 minutes. And then we'll be moving on to the 2 quizzes on that day. Is that clear?
Yes sir.
Okay, so I'll stop the recording then.